We're on 8.2, inconsistent and dependent systems and their applications. We are still looking at matrices. We're still going to use some Gauss elimination. If you want to, you can use Gauss-Jordan elimination, but I think I'm going to stick with just Gauss and back substitution tonight. I'm looking at linear systems, and again, that's any of these where we have 2, 3, 4 variables, depending on how big our linear system is. But we have, in our last section, everything had one solution. Our options on this one, we could have also no solution or infinitely many. And I want to stress again this infinitely many. It is not all real solutions. That would mean anything is a solution. It just means that there's an infinite number of solutions, and we're not going to be able to find and say just one is a solution, but there's many, many solutions for that system. All right, so if you want to look at these pictures, I think the copy you have of the notes, there's a good chance your pictures don't show up. You can always check in your book for these. Thankfully, on the smartboard here, we can see these pictures a little bit. If you happen to have 3 planes, because that's what we get when we have 3 variables, is a 3-dimensional. If we have 3 planes that are exactly parallel to each other, we're going to have no solution. Now notice on the second example, we have 2 planes that are parallel and one cuts through. But because of that, there's no one point that all 3 planes share at the same time, and that's why there's also no solution. Or if our 3 planes intersect, but again, they don't all intersect each other at the same point, then we have this no solution as well. So there's 3 different scenarios where you can have no solution. So visually we can see that, but now let's see what it does mathematically so we know if we have no solution or not. So we're going to do this first example. Trying to slide my page up a little bit so I have more room. And we're going to use the Gaussian elimination to see if this has one solution, no solution, or infinitely many solutions. So let's go ahead and start with our augmented matrix. So remember from 8.1, when we do our augmented matrix, make sure your x's, your y's, and your z's are all lined up, my equal signs lined up, and then my constants are also lined up. I'm going to keep them in the order they are. So my first equation going across, x coefficient is 1, y coefficient is -2, z coefficient is -1. Here's my vertical line for my augmented matrix, and my constant is -5. On my second equation, my x coefficient is 2, my y coefficient is -3, my z coefficient is -1, and my constant is 0. And on my third equation, my x coefficient is 3, my y coefficient is -4, my z coefficient is -1, and my constant is 1. And that will set up my augmented matrix for me. Just like we did in 8.1, my goal is to get 1s down my diagonal and 0s underneath it. Lucky for me, when I start here, I have my first diagonal has the 1 on the top. So now my goal is to get 0s underneath it. So remember, when we're working with our first column, our first row is our target row we want to work with. I'm going to leave the first row just as it is because it's where I want it to be at the time. And I'm going to start with my second row here. I would like to turn that 2 there into a 0. So using my first row, since I'm working on my first column, I'm going to do -2 times row 1 and add it to row 2 to change my row 2. So if I take my first element in row 1, 1 times -2, I get -2, add it to the 2 beneath it, and I get 0. Second element, -2 times -2 is +4, plus the -3 underneath it gives me a 1. My third element in the top row, I get -2 times -1, which is +2. Add it to the -1, I get 1. And on my constants, on the top row, I get -5 times -2, which is +10. Add it to the 0 underneath it, and I get 10. To save myself some space, I'm going to work on my third row as well. And again, I'd like to turn that 3 into a 0. If I'm working on my first column, I like to use my first row to get my intended. So I'm going to do -3 times row 1, and I'm going to add it to row 3 to get my bottom row to change. So up on that top row again, my first element is 1 times -3 is -3. Add it to 3, and I get 0. My second element, -3 times -2 is +6. Added to -4 gets 2. In my third element, I have negative 3 times negative 1, which is 3. Added to negative 1 is a positive 2. And finally, on my last row, or my last column here, negative 5 times negative 3 is positive 15. Added to 1 gives me a positive 16. So I have my goal of my 1 on the top and zeros underneath is done. And again, I'm hoping to preserve that and not change it as I go to the next. My second goal is to get a 1 in my second spot in my second row, and I've already accomplished that as well. So now my goal is to get a 0 underneath that. So I like my first row. I'm going to keep it just as is. I like my second row, so I want to keep that one just like it is. And I'm working on my third row, and I'd like to get a 0 in that bottom middle position. So again, if I'm working on my second column, I'd like to work with my second row to get that. So I'm going to take my second row, multiply that middle 1 times negative 2. So I'm going to go negative 2 of my row 2 and add it to row 3. So I go to my second row, 0 times negative 2 is 0, plus 0 is 0. Negative 2 times 1 is negative 2, plus 2 underneath it is 0. On the third element, negative 2 times 1 is negative 2. Add it to the 2 underneath, I get another 0. In the 10 times negative 2 is negative 20. Add it to that 16 and I get negative 4. All right, so I did get my goal of my first column looks good, my second column looks good, but I do have this issue now. When I look here, I have, let me change colors so it stands out a little bit more. I got this 0 here, and I really want that to be a 1. Just a quick reminder, you cannot add to rows. You can only multiply by rows or divide rows. You may not add or subtract. So I really have no way to get that 0 to anything else. What I have here, if you think about it, is I have 0 x's plus 0 y's plus 0 z's equals negative 4. If the zeros do not equal negative 4, this is what we call a false statement. If you remember when we solve systems, if we have all of our variables disappear and we get a 0 is not equal to negative 4, that's a false statement, and that means I have a no solution. So anytime you're working and all your variables disappear like that and it's not equal, that's considered no solution or a false statement there. So we'll go with the no solution. So let's go to page 2 to see what happens on this one. Just again, a visual for you. If we have infinitely many solutions, by the way, usually when we get one solution with 3 equations, maybe the best way to think about that is your maybe your front wall on your room, your ceiling, and then maybe the left wall. They all come together at that one tiny point up there in the corner, and that would be one solution where they come together at. We saw the no solutions on the opposite page, and now on this page you can see the infinitely many solutions. So in this first picture where they almost kind of, those planes are like spokes, you get this full line. That means you have an infinite number of points on that line that would be part of your solution set. Or if all the planes are exactly on top of each other, once again you have all these points that work for all of those. So that's what it's going to look like if you have infinite number of solutions. All right, so let's look at, that was the visual, so let's look at now the algebra or the numbers and what it looks like when we get an infinite number of solutions. And I will tell you, it's not going to be as easy to just write down the null set or no solution. We're going to actually have a little more work to write down when we say we have an infinite number of solutions. All right, so once again, we're going to use Gaussian elimination. We're going to start with our augmented matrix. So let's go ahead, make sure your x's are lined up, your y's are lined up, your z's are lined up, equal signs lined up, and your constants, and let's make our matrix. So on this one, across the first row, my coefficient of x is 8, my coefficient of y is 5, my coefficient of z is 11, my vertical line to separate my coefficients from my answers, constants, which is 30. Second row, x coefficient's -1, y coefficient is -4, z coefficient is 2, and my constant is 3. And my final equation, my x coefficient is 2, my y coefficient is -1, my z coefficient is 5, and my constant is 12. So here I start with my augmented matrix. Now remember that we need to get our diagonals of 1. To be honest, I really don't want to mess with that 8 up front. I don't want to divide by 8. That's not going to be fun. But don't forget, we can do the switch in rows. So what I'm going to do is I'm going to actually do opposite my row 2 because I'd like to get rid of that negative as well. And just flip-flop it with my row 1. I'm just going to flip them. So that's going to give me a 1, 4, -2, and -3 when I go opposite what was row 2. And I'm going to flip it with that row 1. So I'll move my 8, 5, 11, and 30 to row 2 and leave my row 3 the same for right now. All right, so first goal is met. I have a 1 up in that top. Now I would like zeros underneath it. So once again, if I'm working with the first column to get zeros underneath it, I want to work with the first row to do that. So I'm going to leave my first row just where it's at. I don't know why I just gave myself such little space. All right, now I would like to turn that 8 into a 0. So I'm going to take -8 times row 1 and add it to row 2 to get my 0. So 1 times -8 is -8 plus the 8 underneath it is 0. 4 times -8 is -32 plus 5 is -27. -8 times -2 is +16 plus 11 makes 27. And -8 times -3 is +24 plus 30 makes 54. Big numbers here. All right, and now I would also like a 0 on the bottom row. So I'm going to multiply my 1 times -2 of row 1, and I'm going to add it to row 3 this time. So when I'm working first row or first column, I want to work with the first row in my multiplications. So row 1 times -2. So -2 times 1 is -2 plus 2 makes 0 underneath it. -2 times 4 is -8 plus -1 makes -9. -2 times -2 is +4 plus 5 is +9. -2 times -3 is +6 plus 12 makes it 18. All right, so my goal of 1 on the top and zeros beneath is met. Now I would like a 1 in my second position in the second row. Now, big numbers there, -27, 27, and 54. Of course, the 0 is fine there. The nice thing is they're all divisible by 27, and I would really like to get a 1 in that spot. So I'm going to divide by -27. I like my first row right where it's at. I'm going to take 1/27 or -127 times row 2 for this next move. It's really just dividing by -27. 0 divided by -27 is 0. -27 divided by -27 is 1. 27 divided by -27 is -1. And 54 divided by -27 is -2. And then I'm going to copy the third row down for right now. All right, so I have my goal. My first column looks good. My 1 in the second column, second row looks good, and I'd like a 0 underneath it. To get a 0 underneath it, because I'm working the second column, I'm going to work with my second row. I'm going to leave my first row just as is. I like my second row just as is. So I'm going to go ahead and work with my second row so I can get my second column where I need it to be. I'm going to do 9 times my row 2 and add it to row 3 so that I can get my 9 and my -9 to cancel. So on my second row, 0 times 9 is 0, plus 0 beneath it is 0. In the second second row, second element, 1 times 9 is 9, plus the -9 beneath it is 0. On the third row, second column, third element there, 9 times negative 1 is negative 9. Add it to the 9 beneath it, and I get 0. And finally, in the second row there, the last column, 9 times negative 2 is negative 18. Add it to the 18 beneath it, and I get 0. So once again, I've seemed to have eliminated all my x's, y's, and z's. But what I noticed this time, unlike the page before, this is a true statement because I get 0 equals 0. Since this is a true statement, I don't have no solution. I'm going to have infinite solutions. However, we don't just get to write infinite solutions. We have another task we need to do here. Okay, so this is what we're going to do here, and I'm going to try to keep it on this page so you can kind of see what's going on. We want, and I'm just going to kind of write this here as a hint so you remember this. We're going to write all the variables in terms of the last variable. And so in this case, it's going to be in terms of z. So I know this sounds kind of funny what I just said, but basically what we're going to do is we're going to have z equals z. That's kind of obvious. Okay, so that kind of takes care of this one where we don't know anything, where we're saying z equals z. Now I'm going to go up to this second one here. We're doing this back substitution. Remember, that means 1y minus 1z equals negative 2. Well, z equals z, so I can't really replace this with anything. I'm just going to leave it. So if I want to get y by itself, which the ones really don't matter, so I'm going to get 1y. I'm going to add z to the other side, so I'm going to get z minus 2 when I added z. So here's my z. Here's my y by itself, and that's what we're going to leave y. It's in terms of z. We're going to leave it there. And then I'm going to come up to this third on top to find out for what my x can be. So using that top line there, I get 1x plus 4y minus 2z equals negative 3. Okay, I want everything in terms of z. So I have my x, which I don't know anything for right now. I can't replace that, but I can replace my y. So I'm going to leave this x plus 4. In for y now I'm going to put z minus 2. In for z I'm just doing z, so I leave it z. And I'm going to try to simplify this until I get x by itself, all in terms of z. Distributing my 4, I get x plus 4z minus 8 minus 2z equals negative 3. And I'm definitely running out of space here. I'm going to see if I can do this all in one step here. Okay, if I move, I have a 4z and a negative 2z, which is 2z, and I move it to the other side, it's going to become negative 2z. I have a minus 8, and if I add 8 to the other side, I'm going to get a plus 5. So I can get x in terms of z as well. So there are my three variables all in terms of z. So if I'm going to write this as an ordered triple, okay, I put my x term first, so I'm going to get negative 2z plus 5. Put my y term next, which is z minus 2. And finally my z term, which is z. So I'm going to write my infinite number of solutions in this format. Okay, so let me give you kind of an idea of what this really means. Let's just choose a number for z. This is actually kind of a line, or would all represent this. So let's say z equals 10. If z equals 10, I can plug it in here. 10 minus 2 is 8. I can plug it in here. Negative 2 times 10 is negative 20. Plus 5 is negative 15. And this gives me one ordered triple out of that infinite number of solutions that would work. Now, you can choose any number you want for z, and then find out what the x and the y are that will go with it, and those will continue to be points in the solution set. And there's an infinite number you could choose. So what we have is basically here in our ordered triple is the kind of the formula that finds you all the points that will work. So when you find an infinite number of solutions, you will leave it in terms of all one variable. Now I'm going to be honest, we could have left everything in terms of x or everything in terms of y, But because z is the one that we really wanted in this last line and it disappeared, it's easiest to leave things in the last variable. So that's kind of the rule of thumb that I want to give to you because it'll be easier to do it that way. I'm not saying you couldn't do it the other way, it's just a lot harder. So let's always try to get in the practice of leaving it in the terms of the last variable. All right, next page. Now, this one is called a non-square system, and you're going to see quickly why it's called a non-square system. You'll notice I only have two equations, but my top equation does have three variables. My second one doesn't. By the way, when there's not an x there, we're just going to put a 0x there. Okay, so when we go to write our augmented matrix, we get 3x, or 3 from my x, -1 from my y, 4 from my z, and my vertical line here, so it separates it from the constant of 8. On my second equation, I have 0 x's, I have a +1 for my y, and a +2 for my z coefficient, and my constant is 1. Obviously, this is non-square, because even if I took out the augmented part, I'd have a 2 by 3, and not a 3 by 3 that we like when we're dealing with three equations and three variables. So just to give you a quick heads up, you can't ever truly solve a non-square system, but we can at least work to get some idea about what's happening here. So just like always, I really want to see my ones in this diagonal. So my first one has a 3. If I traded equations, I'd have a 0. That doesn't really help me out any either. So I think I'm just going to take 1/3 of my row 1. Didn't say it was going to be pretty, but we're going to do this. So I'm going to take my row 1 and divide by 3 and find out what I have. So 3 divided by 3 gives me 1. -1 divided by 3, not pretty. I'm going to leave it -1/3. And stress, do not transform, especially one where you round it. Leave it that fraction. Third element, 4 divided by 3, we're going to leave it 4/3. Again, no decimal. And on my constant, I'm going to leave it 8/3. My second row, I'm leaving the same. All right, and you can see my first row, I have a 1 with a 0 underneath it. I like it. I already have a 1 in my second spot, so my diagonal has those 1s, which is what I really like. I'm good as far as doing what I can to solve my system. All right, so let's kind of get a regroup here and figure out what can we do here. By the way, I don't have a third equation. It's the same as thinking that I have 0 x's, 0 y's, 0 z's, and 0 for my constant, which looks like the infinite number of solutions we just saw on our last page. So because of this, I'm going to treat it like I did the last one and just start out saying z equals z. Because just like before, I would have that whatever z equals, that's what I have. And now I'm going to back substitute it. So from the second line, I'm going to get no x's, 1y plus 2z's equals 1. And again, I want to get the y all by itself in terms of z. The 1 in front of the y doesn't matter. I'm going to subtract my 2z on both sides, and I'll have y equals -2z. Oops. Make that a z. -2z plus 1. So there's in terms of that. And once again, too, I would like to write this in terms, for the x, in terms of z. So I'm going to go to that top line. Again, not super pretty, but it is going to work out. Just trust me on this. So I have 1x minus 1/3 y plus 4/3 z equals 8/3. Now, if you're like me, I don't really like to work with those fractions. So quick reminder, multiply the whole equation by your denominator, which looks like it's going to be 3, and we'll make this look a lot prettier faster. Okay, I get 3x. 3 times 1/3 is 1, so just minus y. 3 times 4/3 z, the 3's cancel, I get 4z. And don't forget 3 times 8/3 will just give me 8. Okay, remember my job is to write x in terms of z. I still have a y in there, so I'm going to go ahead and replace my y with that -2z plus 1 that we had for it earlier up here, plus my 4z equals 8. And doing some simplification, don't forget to distribute this negative through, so 3x plus 2z minus 1 plus 4z equals 8. All right, I get 3x. I'm going to try to get everything on the other side here. I have a plus 2z plus 4z. That makes a plus 6z. Subtract it to the other side, I get negative 6z. Add this 1 to the other side, I get plus 9. My x is almost by itself. I need to divide by 3. Everything divides by 3. And x is going to equal negative 2z plus 3. So once again, I'm going to write this ordered triple. My x is the first one, so negative 2z plus 3. My y is next with negative 2z plus 1. And finally, my z is just z. So that's how I can represent this non-square system. And it just tells me if I know a z, I can figure out how the relationship of the x and the y will go towards that z. All right, one last page, and it's a doozy. Let's try this story problem here. All right, so this is our applications. This is where we really use systems, is when we put them into real life and these story problems, good, bad, or indifferent. That's where they're most useful at. All right, we have 3 foods that have the following nutritional content per ounce. Food 1, food 2, food 3, and we have vitamin A, iron, and calcium that we are looking at. So just to kind of be able to write some equations here, let me change my color. Okay, I'm going to call food 1 X, food 2 Y, and food 3 Z. Okay, that means for vitamin A, I have 20X. I have for food Y, I have 30 Y, and for food 3, I have Z, which is 10Z. And notice down here, a diet can consist precisely of 220 units of vitamin A. So that means 20X plus 30Y plus 10Z should equal exactly 220. And following the same idea here for iron, I know I need 180 units of iron, so I'm going to get 20X plus 10Y plus 10Z equals 180. And then finally on the calcium, following that same idea, I need 340 units of calcium. So I get a 10X plus 10Y plus 30Z equals my 340. So taking my information from my chart, I can write my system of equations. So I'm going to go ahead and write my augmented matrix off of this set of data. So I have 20, 30, 10, and behind my vertical bar 220, 20, 10, 10, 180, and 10, 10, 30, and 340. All right. So it tells us what the diet needs to consist of. We have this condition though. Switching colors so we can keep track here. The dietitian ran out of food 1. So food 1 is my X's. Okay, if you think about that, food 1 is my X's, but I ran out of it. This column's gone. I don't have it because I ran out of it. So I am left with this non-square matrix using the food 2 and food 3. So can I meet my dietary requirements with what I have? So if I think about it, I want to get the ones in my diagonal and such like that. All right. I'm going to be honest. I'm going to try to do a couple things at once. I would like to take row 2 to row 1 and divide by 10 at the same time. So 1/10 of row 2, and I'm going to switch it with row 1 just to move that. So I'm taking this row right here and dividing by 10. That gives me a 1, and an 18. And I'm going to leave my, if you're okay with it, I might divide row 1 by 10 as well, just to make them smaller. That'll give me a 3, 1, and 22. And while I'm at it, I'll take 1/10 of row 3 too, just to make sure I get my number smaller. So 1, 3, and 34. All right, so I have my 1. I would like some zeros underneath it. So let's see what I can do space-wise here, trying to conserve some space. All right, I'm going to leave my first row. I like it. If I do negative 3 times row 1 and add it to row 2, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus 1 is negative 2. Negative 3 times 18 is negative 54 plus 22 is 54, negative 32, I believe. And then I'm on to the second one. Let me double check my math in my head there. I think I got that right. Okay. And my bottom one, it looks if I just take row 1 and I subtract row 3. And I can do that. I can just subtract or multiply by negative 1. If you want to think about negative row 1 plus row 3, that works as well. So negative 1 plus 1 gives me a 0. Negative 1 plus 3 gives me a 2. Negative 1 times 18 is negative 18 plus 34 gives me a 16. All right. Now I want to get a 1 on my, this first row looks good to me, but I need to get a 1 in this spot right here. I'm going to divide by negative 2 on that one. Let's see, I'll come over this way. I'm going to just move this way. I like my first row, 1, 1, 18. I'm going to do negative 1/2 of row 2, so I get 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. Negative 32 divided by 1 is 16. And I know this seems a little unconventional, but if you look at these two rows right here, let's just go ahead and add them together right now, and I can get my 0. So 0 plus 0 is 0. Negative 2 plus 2 is 0. Negative 32 plus 16 is negative 16. And what you're going to notice here, I love what I have here and here, but unfortunately across the bottom here, I have a false statement. Which means I have no solution here, which means I cannot meet my dietary requirements if I run out of food 1. All right, and that's we're using that non-square on that one. So let's try B here. Now suppose all 3 foods are available. Use the matrices to give 2 possible ways to meet the iron and the calcium requirements with the 3 foods. So let's go back to our original, and notice here iron and calcium requirements. So what that means is I'm not worried about my vitamin A. So to be honest, on my top one, I really don't need that top equation where it equals 220. I really only need to use the equation 10 plus 10z equals 180, and the 10x plus 10y plus 30z equals the 340. Those are really the only 2 I need to, since I'm only worried about the iron and the calcium. So my vitamin A is not needed. I'm going to set up my matrix, and I'm also going to divide everything by 10 to keep it smaller. So the first one's going to be 2, 1, 1, and 18. Second one's going to be 1, 1, 3, and 34. Once again, I have a non-square matrix, which means I'm not going to be able to solve it, but I am going to be able to find the conditions or find everything in terms of z, if that makes sense to what we've done before. All right, let's just flip-flop row 1 and row 2, because I really want 1 up in that top. So 1, 1, 3, 34, and 2, 1, 1, 18. And now I'm going to do negative 2 times row 1 and add it to row 2 to get my 0 underneath. First row stays the same, 1, 1, 3, 34. Second row, so on the top, 1 times negative 2 is negative 2 plus 2 is 0. 1 times negative 2 is negative 2 plus 1 is negative 1. Negative 2 times 3 is negative 6 plus 1 is negative 5. Negative 2 times negative 34 is negative 68 plus 18 gives me a negative 50. And I'm going to do a little real quick, not really cheating. If you just think of taking that second row and multiplying by -1, I'm going to make this +1, +5, and +50. And I have a good matrix with a 1 here, and my next one has 1. And again, we're thinking of that last row is 0, 0, 0, 0, which means we're going to start out with z equals z. All right, so we have this, and now we're going to try to find our y. So using my bottom row right here, I have y plus 5z equals 50, which means y can just be negative 5z plus 50 when I subtract 5z to the other side. So that gives me my y. And now to find my x using my top line, I have x plus y plus 3z equals 34. I'm going to replace my y with my value from above. So x minus 5z plus 50, that's my y up there, plus 3z equals my 34. All right, let's clean this up so I can get x by itself. So x, I need to make sure I'm not getting these confused here. X, negative 5z and 3z makes negative 2z. Add it to the other side, it's going to be positive 2z. Plus 50, subtract that from 34, and I get negative 16. So I get 2z minus 16 for my x. So my ordered triple here would be 2z minus 16, negative 5z plus 50, and z for my ordered triple. All right. Now, going back to my question, though, it asked me for 2 possible ways to meet those requirements. So I get to choose now for my z and what my z is, and then find that from there. So it doesn't matter. You get to choose 2 possible ways. So I'm going to plug in, I don't know, I could plug in, careful here, if I try to plug in 1, I'm going to get a negative number on my x up here, so that's not going to be good. So it looks like I need to go at least to 8 so I don't get a negative number. So I'm going to choose 8 as my first one. 2 times 8 is 16 minus 16 is 0 for my x. Over here on my y, negative 5 times 8 is negative 40, plus 50 gives me 10. So there's one possible combination, 0 of the food 1 with 10 of food 2 and 8 of food 3. You'll notice too that I'm going to be kind of limited. I can't go too big, because if I go too big, my y will become negative, and I can't have negative of anything. So I got to keep it close. So 8 worked. I think I could go as far up as 10. 10 would give me a 0 in the middle here. Negative 50 plus 50 is 0. And it's okay to have 0 of a food, just not negative. And when I plug it in for the x, 2 times 10 is 20, minus 16 is 4. So to be honest, I think the only numbers I could really use are 8, 9, and 10, because I can't get those negatives in there. So those are 2 possible combinations. So there we have the inconsistent and dependent systems and how we can use them, where they come into effect. And again, remember, if there's infinite number of solutions, or if we don't have a square matrix, make sure you get everything in terms of z. All right, you'll notice on my homework that I was very picky and I chose specific problems here, 3, 6, 9, 10, 15, 21, and 36. And the reason I did is so that you could get practice at each type of system. So please try those systems, work on them, send me an email, send me something in the stream if you're confused, and if we need to, we'll do a couple of them together so they make a little more sense. Good luck.